Assalamualaikum warahmatullahi wabarakatuh. Okay, let's look at an example on Fourier series. Given a periodic function gx with period 2 pi, okay, the period is 2 pi, and is defined as gx equal to 1 plus x between 0 to pi, and pi when x between pi to 2 pi, and we need to sketch the graph of gx for negative 2 pi, x between negative 2 pi to 2 pi. Okay, determine if gx is an even or odd function or neither, and hence find its Fourier series. Okay, the first solution will be, the first solution, that means the solution for the A would be, okay, we need to sketch the graph. So when we have two function here, because this is a piecewise function, so this is the first and this is the second. So right now, for the first one, when x equal to 0, y equal to 1. And when x equal to pi, we have y equal to 4.14. Actually, for 2, you don't have to do this actually. Because, as we can see, this is a constant. When it is a constant, for the 2 is automatically a straight line y equal to pi, which is 3.14. Take just 2 decimal places to plot the graph. Okay, because it will be easier. Okay, so right now, between 0 to 2 pi, okay, between 0 to 2 pi, as you can see here, we sketch the graph. It will be like this, and this is the straight line, and this is the straight line for the constant. Okay, since we need to sketch this graph between negative 2 pi to 2 pi, so we just repeat the same pattern on the left. Okay, like this. So that means the straight line from 0 to pi will be from negative 2 pi to negative pi. And this straight line for the constant y equal to pi will be from negative pi to 0. Okay, remember to label your axis. Okay, your axis. Okay, so right now, based on this graph, as we can see, fx is actually neither odd nor even function. Sorry for the grammar. Okay, neither odd nor even function. Okay, so that means this is a full range series. Okay, why is not an odd function? Because as you can see, this is not symmetry at the origin. If it is symmetry at the origin, by right, when you have the graph on the first quarter, the reflection mirror for an odd function should be on the third quarter. Okay, and then this is not an even function as well, because it is not symmetry at the y-axis. If it is symmetry at the y-axis, that means this line should be like this. Okay, from there we know that this is not an even function. This is neither an even function nor an odd function. Okay, so given to us, as you can see earlier, the period is 2 pi. So right now, 2L is equal to 2 pi minus 0. The full period is 2 pi. So L is equal to pi. Okay, so therefore, Fx equal to A naught over 2 plus summation n from 1 to infinity an cos n pi x over pi, because n pi x over L. So here we can simplify the pi, and so that's here for sine. And therefore we have fx equal to a naught over 2 plus summation n from 1 to infinity a of n cos n x plus bn sine n x. Okay, for a naught, we need to calculate from 0 to 2 pi. It is the same as actually a naught is equal to 1 over L integrate from c to c plus 2L, okay, fx dx. Okay, this is what we are going to apply for this question. So that means, instead of negative L to L, this is actually c to c plus 2L. Okay, so integrate from 0 to pi would be 1 plus x. So as you can see here, I did separate. So this one is 1 over pi. For 1 over pi, integrate 0 to pi, 1 plus x dx. And then plus, I repeat, 1 over pi, integrate pi from pi to 2 pi with respect to x. Okay, I just separate it because it will be easier for us to integrate instead of you need to do a huge bracket here. Okay, So this one, integrate 1 will be x. X is x squared over 2. And pi will be pi x. Substitute the value of pi minus the substitution of 0. Remember, even if it is 0, please write 0 to make it clear. Okay. And here pi plus pi squared over 2 plus 1 over pi. Here is 2 pi squared minus pi squared. And therefore, this one simplifying, we have 1 plus pi over 2. Okay. Plus 2 pi squared minus pi squared is pi squared. Divided by pi is pi. Therefore, A naught is equal to 2 plus... I did a mistake here. It is not 2. A naught is equal to 1. Sorry. 1 plus 3 pi over 2. That will be correct. Okay. This is for A naught. Okay. So, AN is equal to 1 over pi. Integrate 0 to 2 pi fx cos nx with respect to x. Why nx? Because n pi x over pi. Okay, over L. See, right now. Right here. It should be the same. Cos nx. We refer to this actually. Okay. So, here. Just take a look. I did separate again. 1 over pi, integrate 0 to pi, 1 plus x cos nx with respect to x. And here 1 plus pi, integrate pi to 2 pi, pi cos nx with respect to x. So I separate them. 1 over pi here, integral. And plus 1 over pi, integral. Another integral. So for this one, the first term, we need to use integration by pi. Okay, this will be the solution then. Okay, cos nx here, we will have this one. And then next, for this, actually, if you realize earlier, you can actually cancel out this pi here. Okay. As the same I did here, actually. Okay. So, right now, remember the diagonal line. Positive, negative. For u, we differentiate. For dv, we integrate. Okay. It will be like this. Okay. Plus, 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 positive. Positive, negative, negative will be positive again. Okay. Substitute pi and 0. Sin n pi is equal to 0. And sin 0 is equal to 0 here. Okay. That's why I did root 0. And here 1 over n squared cos n pi minus 1 over n squared. And this one will be plus 1 over n sin 2n pi minus n pi. Sin 2n pi is equal to 0. Okay. And this one also equal to 0. Therefore, we have A of n equal to 1 over pi n squared cos n pi minus 1. Okay. For B of n, it will be 1 over pi. Integrate from 0 to 2 pi fx sin nx with respect to x. So, here, as I've written, okay, separately too. And this one, you can actually simplify pi here. But it can also be done here. Okay. So, right now, we need to do another integration by part. For u, we differentiate. For dv, we integrate. The earlier one will be for cos nx and here for sin nx. So the answer will be different. Okay. Don't just simply judge that you can use the same tabular. Okay. And next, here b of n is equal to 1 over pi. Positive, positive, negative, negative. Remember to write 1 plus x in bracket because there would be a lot of difference if negative 1 plus x in bracket or negative 1 plus x directly. Okay. And next, positive, negative, negative will be positive again. And this one, integrate. This pi will be here. Integrate pi to 2 pi sin nx with respect to x is negative 1 over n cos nx from 2 pi to pi. Okay, remember substitute upper limit minus the lower limit. And here too, upper limit minus the lower limit. This one will be negative 1 plus pi over n cos n pi plus 1 over n squared sin n pi. So sin n pi equal to 0. And then sin 0 equal to 0. Next, cos 2n pi plus cos n pi. Okay, take note that cos 2n pi is equal to 1. Because cos n pi is equal to negative 1 power of n. So cos 2n pi is equal to negative 1 power of 2n. Anything power of 2 even number would be equal to positive back again. Okay, 1. So here we have negative 1 over n. I actually separate them. Okay, negative 1 over n cos n pi, negative pi over n cos n pi plus 1 over n. And here negative 1 over n. Okay, this side. Okay, this side already because this is plus 1 over n. Negative 1 over n here. And then plus 1 over n cos n pi. Okay. The reason I separate them, see, we can actually see the clear comparison here where we can actually sum it equal to 0. This one, we are left with negative 1 over n pi. Okay. Wait a second. This one is negative 1 over n. Sorry. This one does not equal to 0. So right now, after simplifying, we do have, just ignore what I said earlier about equal to 0. Okay, right now, simplifying this part, we will have negative 1 over pi n pi cos n pi minus 1 over n cos n pi plus 1 over pi n. Okay. This one actually because we can simplify the pi, that's why we have 1 over n. Negative 1 over n plus 1 over n cos n pi, and it will be 0 for this part. Okay, negative 1 over n cos n pi. Here, negative 1 over n cos n pi plus 1 over n cos n pi can be cancelled out equal to 0. So we are left with 1 over n pi, 1 here, minus cos n pi, minus 1 over n. This is our Bn. Okay. Oh, there's a hiccup there, sorry. Okay, sin n x, let me see the one above. Okay, that's good. Okay, here, fx is equal to, since I did make a mistake earlier, this one is not 2, it is 1. Therefore, this is 1 over 2. Because A not over 2. Okay, fx equal to 1 over 2 plus 3 pi over 4. You don't have to put bracket here because it is at the front. Okay, plus summation m from 1 to infinity. Remember this, open bracket. Okay, this one to open the bracket. Open and close the bracket. Okay, so this is actually A and n. Okay, cos nx plus this is Bn sin nx. Remember, even for Bn, you need to write in bracket. Okay, don't simply write plus 1 over n pi in bracket 1 minus cos n pi minus 1 over n sin nx. Because theoretically, it will be 1 over n only multiply with sin nx. But it is actually b of n the whole multiply with sin nx. That's why we need to write write a bracket here. Okay, that's all for this example. Thank you and pardon for any hiccup here and there. Thank you. Assalamualaikum.